So the new unit, Unit 4 is thermodynamics. We are going to be looking at the relationship between temperature, thermal energy, and heat. Okay? Now, there are 3 definitions that you are going to be responsible for understanding. The first definition that you're going to be responsible for understanding is thermal energy.
Why are you complaining already? You literally have your friend 3 words.
Thermal energy, guys, thermal energy is going to be identified as ET. It is going to be defined as the total amount of energy in all of the particles of an object. The unit for thermal energy is joules. Okay. That's one of the definitions. Another definition you're going to be responsible for understanding is temperature. That will be identified in formulas as just a capital T. Okay. The temperature is defined as the average energy of the particles in an object. The unit here is going to be degrees Celsius. Or Kelvin. Okay. The next unit, or the next definition that you're going to be responsible for working with is heat. It is different, which is going to be signified by the capital Q. And this one, I don't know why it's Q. You're just going to have to live with it. Heat is identified as thermal energy that is being transferred and the unit for thermal energy is going to be the joule. So I know that thermal energy and temperature and heat all seem to be very similar, but thermal energy is the total amount of energy in each particle inside of an object. Temperature is the average energy of all of the particles inside of the object, and heat is the amount of thermal energy that is transferred at some point in the system. So we need to talk a little bit more about thermal energy. And the way that we're going to talk about thermal energy relates to kinetic theory of matter. The kinetic theory of matter tells us a couple of things. First of all, it says that matter is made of tiny particles called atoms, that are constantly in motion. If they are constantly in motion, what type of energy would the particles have?
Thermal.
Kinetic energy. Another thing that we need to know about the kinetic theory of matter is that the more mass an object has, the more energy it could have. The more energy an object has, the faster the particles are moving. And energy tends to be transferred from particle to particle as heat. And again, I know that this is a lot, so bear with me.
Yes.
We have already defined temperature as the average.
Do we have to write this again?
Well, if you don't want, I guess not. The temperature is the average energy of the particles in an object
Leave.
and there are 3 units for temperature that you should at least understand that exist. The 3 units for temperature
Celsius, Fahrenheit.
are, first of all, degrees Fahrenheit, we will not use Fahrenheit in class. There is degrees Celsius, which we will use in class, and there is Kelvin, which we will also use in class, but it does not have degree symbol associated with it. Now, to explain the difference, okay, gentlemen, to explain the difference, Kelvin is a direct measure of particle movement, whereas degrees Celsius is a measure of heat transfer. So Kelvin actually measures the energy that an individual particle has, whereas Celsius measures the transfer of heat of those particles, or the transfer of energy of those particles. So there is a subtle difference, okay? Now, the other thing that you need to understand about temperature is that there is something that we refer to as absolute zero.
You can never reach absolute zero.
Correct, you can never reach absolute zero, to our knowledge.
Phil and I called it.
Now, this is defined as temperature which theoretically says that at which particles are no longer moving. Okay. The value of absolute zero in Kelvin is 0 Kelvin. The value of absolute zero in degrees Celsius is negative 273 degrees Celsius. And in degrees Fahrenheit, which I said we're not going to use, but just so you have an idea, is negative 459.4 degrees Fahrenheit. So this is incredibly cold, but it is the point at which particles stop moving. Okay? So, according to the SI system of units, which is known as the international system,
These worldwide games.
You know, it's quicker to say World Wide Web than.
I saw it on Instagram, I know.
so the SI system of the SI unit for temperature, hang on,
So funny. I know. I'm a doctor's appointment.
is the Kelvin. Now, the international system is a organization that is based in France, and its French actual name is Système des International of Units. So when it translates in English, it goes International System of Units, because they flip-flop their verb or adjective or whatever. So it's the SI system, is basically is what we've decided to be. Now,
Team got fired.
to convert from Celsius to Kelvin, you need the following formula, which is Kelvin is equal to degrees Celsius plus 273. So if I said that we were going to convert 0 degrees Celsius to Kelvin, we would take Kelvin is equal to 0 degrees Celsius plus 273, and we would say that the Kelvin temperature is 273. Okay? Now, if I ask you to convert 25 degrees Celsius to Kelvin, we would take Kelvin is equal to 25 degrees Celsius plus 273. So Kelvin would equal 298 K. Now, at 0 degrees Celsius, just so that you guys are aware, 0 degrees Celsius is equal to 32 degrees Fahrenheit. That's the freezing point of water. okay? 25 degrees Celsius is roughly 70 degrees Fahrenheit. So that's room temperature. So at 25 degrees Celsius, we're at 70 degrees Fahrenheit, we are at 298 Kelvin. If I ask you to convert from Kelvin, I told you, didn't I? Weird.
Are we close to the end, or are we just like in the middle?
To Celsius, you would use the following formula, which is which is degrees Celsius is equal to K minus 273. So if I gave you a value like convert 373 Kelvin to degrees Celsius, we would take degrees Celsius is equal to 373 K minus 273. That would give me a value of 100 degrees Celsius. Remember, 100 degrees Celsius is equal to the boiling point of water is equal to 212 degrees Fahrenheit. You are going to be asked, ladies and gentlemen, you are going to be asked to draw particle diagrams. And the rules for drawing particle diagrams are as follows. There's only two, but there's multiple parts. Rule number one, know your states of matter. There are three states of matter that you are responsible for understanding. A is solid. B is liquid. And C is gas. For a solid, the particles are touching and organized. You got this? For liquid, the particles are touching but not organized.
Particles are not touching, are touching, and not.
And for a gas, the particles
Are not touching, but
are not touching and not organized. Okay, so those are the three states of matter you are going to be responsible for being able to draw. The other thing that you need to keep in mind is mind the kinetic molecular theory. I told you.
Three more of those guys. Come on. Stop complaining.
Which says that matter is constantly in motion and we show motion with motion marks.
Does that say mind?
Mind the kinetic molecular theory. The other thing that we need to keep in mind when it comes to kinetic molecular theory, more motion marks equals more motion. You are going to be asked to be able to draw solids, liquids, and gases using the information that I just described to you. So, for example, if I ask you to draw a solid, you will draw particles that are touching and organized with some type of pattern. Okay? If I ask you to draw liquids, you will draw particles that are touching but not organized. No pattern. And if I ask you to draw a gas,
It'd be all over.
they would definitely be all over the place. But if the gas is cold, it will have some degree of motion marks. But if the gas is hot, it's going to have more motion marks. Now, should the liquids have motion marks? Probably.
Yeah.
Should the solids have motion marks?
No.
Yes, but they should be even less. So if the liquid would have some motion marks, right? The solids would have even less motion marks. But all of the particles have some kinetic energy. So the other thing you might want to keep track of is gases are touching, not touching rather. They are not organized. There is no pattern. But you might want to know that solids are low energy. Gases are high kinetic energy. And liquids, I don't know, are medium kinetic energy.
Open sesame.
Something like that. Heat flow, we have to be able to keep track of where thermal energy is versus where thermal energy ends up in a system. So heat has the tendency to flow from hot to cold. From hot to cold. In class, we are going to show heat flow using an arrow.
That sucks.
Okay? And the larger the arrow, would indicate that there is more heat flow. So, if I have two objects, that happen to be touching. One is hot, the other is cold. The arrow would show that we are transferring energy from hot object to a cold object. And that energy transfer would continue until both objects are at the same temperature. So heat flows until both objects are at the same temperature. Now, your homework is to do worksheet number 1 in the packet. It is a 2-sider, ladies and gentlemen, a 1-2-sider. Okay? It's 1 through, I believe, 7? 6? 1 through 6. Enjoy. You have the rest of the hour to work on it.